We have server farms capable of processing trillions of calculations a second. Yet, when a hospital network drops offline, or a farmer tries to adapt to a sudden microclimate shift, that theoretical computing power hits a wall. Systemic failures in agriculture, medicine, and physical security still happen every day. Code that performs perfectly in a sterile laboratory environment is effectively useless if it cannot survive contact with unpredictable, highly vulnerable real-world conditions. Bridging that gap requires a different approach to engineering. Krkthn Solutions, a technology hub operating out of India, is building a blueprint for exactly this kind of deployment. They focus on producing locally optimized, enterprise-grade tools designed to function where theoretical models usually break down. Their guiding philosophy is explicit: to provide highly advanced, secure artificial intelligence software solutions that tackle everything from the daily problems of the common man to international security challenges. To understand how they actually achieve this, we have to look past the raw code and examine their catalog through the lens of human survival, specifically health, infrastructure, and security. Starting with human health, the engineering challenge is shifting algorithms from passive observation to direct, reliable human intervention. This scan demonstrates the XAI X-ray Anomaly Project. Medical AI is often a black box, giving unexplained answers. Using GradCam to create visual heat maps over the scan, this system highlights the exact pixels flagging a tumor, turning it into a fully explainable tool. Look at this hub-and-spoke model illustrating a decentralized method called federated learning. Instead of hospitals pooling sensitive patient scans into a vulnerable database, the AI trains locally on isolated servers. The network only shares algorithm updates, guaranteeing patient files never leave the building. This video of continuous sign language shows another angle of their human-centric engineering. The sign-to-text translator runs a real-time video pipeline that instantly converts these fluid, continuous gestures into readable text, removing friction from critical communications. Integrating a secure, localized core into health algorithms provides a stable framework for scaling medical AI across diverse hospital networks while maintaining strict patient confidentiality. Stepping outward from the human body, the focus turns to the physical infrastructure and natural resources that sustain us. In this high-altitude satellite footage, we can see the deforestation tracker at work. It applies multispectral image segmentation to the landscape below. This process analyzes wavelengths of light invisible to the human eye. It quantifies minute changes in canopy density to immediately alert authorities to illegal logging zones. Down on the ground, the Precision AgriBot applies a specialized vision model to autonomous tractors. By visually distinguishing between cash crops and invasive weeds in real time, it enables targeted spraying and eliminates mass chemical dumping. This logic flowchart maps out what engineers call an edge-deployed model. In systems like Krkthn's drone smoke detection, the drone processes aerial video to spot early wildfire signs entirely on its own onboard hardware. It severs its reliance on a cloud server. When fighting a wildfire or managing remote crops, internet connectivity is rarely guaranteed. True infrastructural AI has to be geographically independent, capable of making split-second decisions in total isolation. Finally, we reach the security domain, which has to protect these physical and digital systems against increasingly sophisticated fraud and direct attacks. This wireframe mesh illustrates the deepfake video verifier. It uses spatiotemporal analysis to track unnatural blink rates. Furthermore, it scans video frames at the pixel level, hunting for microscopic blending artifacts where an artificial face was grafted onto a jawline. To protect the AI models themselves, an adversarial defense layer is built in. It acts as a digital purifier for neural networks, detecting and stripping away invisible layers of static noise that bad actors use to confuse or trick machine learning systems. Connecting this complex digital defense back to the physical world, we see systems like the frictionless checkout. High-speed vision models process simultaneous items sliding past a register, creating secure grocery billing in a fraction of a second. Modern security functions as a predictive layer, anticipating and neutralizing structural vulnerabilities before they can be exploited by an external threat. Reviewing the scale of this catalog, it becomes clear that these are not isolated lab experiments. From thermal fever screening to predicting traffic choke points, this is a holistic ecosystem of enterprise-grade tools, and it is heavily supported by normal foundational engineering. Tools like the offline POS fallback ensure that retail backends seamlessly switch between cloud syncing and local databases, preventing system crashes when external networks fail. This diagram of a compressing neural network illustrates a quantized language model. By systematically shrinking massive AI models without losing their internal logic, projects like the offline LLM legal system can summarize highly sensitive contracts on local, disconnected machines. This vast array of hyper-applicable, mathematically secure technology represents Krkthn's core mission, natively built and rigorously tested in India, ready for global deployment. The future of software is defined by a resilient, secure core that translates computational intelligence into permanent solutions for human problems.